In this last video introducing objects in Python, I'm going to talk about the idea of inheritance. The basic idea of inheritance is that you can define objects which depend on other classes and inherit their properties. We're going to be building on the example that we have created so far, so let me briefly review what we did in the previous videos. We're thinking about products in a grocery store, and we began by noting that all products in a grocery store have certain properties which are very likely to be important to the business. In particular, all products will have an SKU, a product name, a brand, a manufacturer, and dimensions, which may be very important in storing the product, and similarly a weight. So what we had done previously is create a class product. It had an attribute called version that is created for every instance of the product. But we mostly worked on using the private function init, that's underscore underscore init underscore underscore, in order to define attributes that we were interested in. So that's what we've done in this function init. We went on to define a couple of methods. One that was called print, which printed out the information in a reasonable format. And the second allowed us to store and retrieve a phone number of the manufacturer. So we created this method called setPhone. And setPhone illustrated the idea of private data by enforcing a particular format on the phone number and then storing the value where it cannot be modified from outside of the object. So the setPhone method will store the phone number after checking its format, and then we need a getPhone method in order to be able to read the phone number. Now I've gone ahead and added two more methods to this product object that illustrate other things that you can do. For example, I've created a method called printShelfVolume that simply calculates the volume of the product by multiplying the width times the depth times the height, and then it prints this volume out in an attractive way. It says shelf volume equals so many units cubed, and actually returns as a number the volume as well. And then in a similar fashion, it seems like a useful function to have as a part of the object is to calculate the footprint area. So the footprint area of any object is just the product of the width times the depth, so that just returns that. So that was our product object. Now, what we're going to do in this video is to define a special class for milk products. So we're going to do that by saying class milk product, and now this time, instead of just having the colon right away, we have open parentheses and close parentheses and product in between. And what this tells Python is that this milk product is going to inherit all of the properties of product. We're going to understand that better as we get into this, but that's the basic idea. Milk product now is derived from product, so it inherits all of its properties. So if we create a milk product, the first thing we might do is have some variables that are defined for all milk products. In particular, if it's a milk product, its category is dairy, so I've set that, and its method of storage is refrigerated, so I've gone ahead and set those variables as well. So we now come to the variables that are unique to each milk product that are created. And we define these in the same way that we define the characteristics of product, namely by defining a private internal function, underscore underscore init underscore underscore, that will define the attributes that we need. For a milk product, the arguments to the init function start as before with self, but they're going to include all of the arguments that were part of the original product class definition. So for example, SKU, name, brand, manufacturer, DIMS, weight, and weight units were all a part of the original product class. I'm going to go ahead and show you that and show you a little bit of a trick with Spyder. Specifically, I can split this window by moving my cursor over to the numbers over here and right-clicking and then going split vertically. And I'll get two windows here. I'm going to move down to this class milk product in the bottom window. Here it is. And in the top window, I'm going to go back up to the class product. Here it is. And you can see exactly what the arguments to the init function were for the class product. They were SKU, name, brand, manufacturer, DIMS, weight, and weight units, and those are repeated here in the definition of the init function for milk product. Now notice that in my definition of the init function for milk product, I've used the variable name equals none several times through here, and you'll recall from my video on defining functions that what I'm doing here is specifying a default value for this variable if it is left out. So for example, in defining the milk product, required arguments are the SKU and the name, but all of the other arguments in here are either set to a default value or set to the default value none, which is essentially code for them not being set. So brand equals none says that if brand was not specified, it will be set to none. Manu set to none if it's not specified, DIMS to none, weight to none, the weight units to none, the volume to none. Fat category is going to be whole. What we're thinking here is the way milk is specified is things like whole milk, 2% milk, 1% milk, skim milk, and so on. So the default here is going to be whole milk. The expiration date is set to none, and everything else here is set to none. This allows us not to have to specify all of these arguments if we don't want to. SKU and name are always required, but none of the others are required. And notice that I've changed this from my definition for the class product, where all 7 of these dimensions were required. Now, when my milk product instance gets created, category will be set to dairy, storage will be set to refrigerated, and then this private function init will be called. And it will be the responsibility of the init function to initialize this object. I don't really want to have to repeat, however, the initialization that occurred in the class product, and I can rerun product's initialization in the following way. I type the name of the class that we are inheriting from. In this case, the class milk product is inheriting from product. And then I go dot and then underscore underscore init underscore underscore. And then I call init in exactly the same way that it was called in the definition of the class product. So if you look right through here, you'll see that this set of arguments for product.init is exactly the same as the set of arguments for init in the product class. Now I have to handle the things that are unique to the milk product. And the unique attributes of the milk product that we're going to use in our example here is the volume. Again, that was whether it was a gallon, half gallon, or so on. The fat category, which was whether it was whole milk or 2% fat milk or 1% or skim. The expiration date, so all dairy products have an expiration date. This is a food product, so it now has the government's food labeling requirements, and some of those are the serving size, the number of servings per container, the calories in a serving, the grams of fat in a serving, and the calories from fat. And of course there's a whole lot of other stuff that goes in those food labels, but I'm just going to use this set as an example. This piece of code right here creates all of the attributes that are special to a milk product. Now, in addition, we're going to go ahead and set the phone number if the phone number exists. So we're going to test whether phone, the variable phone, is set to none. And if it's not set to none, we're going to call self.setPhone. The method setPhone is picked up from the class product. You'll recall that at the end of the definition of the class product, we define this method setPhone. The method setPhone has not been defined in the class milk product at all. If you skim back up through the definition of milk product, you'll see that nowhere in here is there any definition of the setPhone method. But because of inheritance, we can use the setPhone method just as if we had defined it in this particular class. In particular, what's actually happening in Python is the interpreter looks for an attribute, in this case a method, setPhone, and if it doesn't find it in the definition for milk product, it then looks back into the objects that we're taking inheritance from. So basically, if setPhone isn't defined in milk product, the interpreter looks at anything that we're inheriting characteristics from and then goes to try to find the attribute or the method in the definition of this class that we are inheriting from. So that's what's going on, and in fact that's the logic behind how this inheritance works. If the name can't be resolved in the current class definition, the interpreter looks back into the class definitions of the objects that we're inheriting characteristics from. So that's a definition of a special class for milk products. Just to complete my example, I'm going to now specify a special class for laundry detergent products. For the laundry detergent products, I have in my init function all of the same variables that were in product, so the first 8 of them are identical. I've specified some defaults in here as I did with the milk product class. We do have special characteristics for laundry detergents, however. One of them is that the size of the product box is really rated by the number of loads. So number of loads is important. In addition, right now laundry detergents are classified into 2 major types. Those which are called high efficiency and those which are regular or not high efficiency. The HE, high efficiency detergents, are necessary for front-loading washers. Regular detergents create too many suds for a front-loading washer. In addition, another important characteristic of a laundry detergent might be its form. Its physical form is what I'm thinking here. For example, it might be a powder, or it might be a liquid, or it might come in little packages that are called pods, and so on. In addition, laundry detergents frequently have a scent, and in this particular definition of init, I've also allowed a manufacturer's phone number to be input if you'd like. Now, this laundry detergent product gets created in exactly the same way. Our init for the laundry detergent product calls product init with the first 8 arguments, self, the SKU, the name of the brand, and so on. And then it goes on to define the characteristics that are special to a laundry detergent product. So in particular, it creates, for the instance, a number of loads, which is going to be equal to the argument to the init function numLoads. It creates a sudsing level, which is equal to suds level. It creates a physical form, which comes from the form argument, and it creates a scent, which comes from the scent argument. And in addition, as with the milk product, if the phone number is defined, then we set the phone number. I've now given you an example of 2 classes that derive from the product class, which is more general. product had characteristics in it that virtually every product in a grocery store would have. The milk product class and the laundry product class inherit those characteristics from product, but they also have characteristics special to those particular categories of products. So it's time to execute these class definitions and then create a couple of instances that we can experiment with just to understand exactly how the various attributes have been created. First, I'm going to remove the window split. So I'm going to put the mouse cursor over on the left-hand side over the numbers and right-click and do close this panel. And now I'm going to go ahead and scroll to the top of the file. And I've taken each class and put it in a cell. Cells, you will recall, are defined by pound, %%. But then I can execute a cell by putting the cursor into the cell and then hitting Control Enter. So the very first thing I'm going to do right now is to run the class definition for product. Now if we go over to the console and scroll back up, you'll see that all of the code defining the class product has been executed, starting right here. Okay, so now I'm going to go ahead and move down in the file till I get to the class milk product. And I'm going to stick my cursor somewhere in that cell and type Control Enter, and we'll have defined the milk product. So if you looked at the console, its definition was flying by. Finally, I'm going to define the laundry detergent product by selecting somewhere in the cell and doing Control Enter again. So the laundry detergent product is now defined. So I'm going to move down to the bottom of the file and create two instances. One is milk 23, which is from its SKU number, which is a milk product, and the other is det 16, which is a laundry detergent product, also numbered from its SKU number. Now I want to go ahead and split the screen again so you can see how the creation of the instance corresponds to the code in the class that defines the instance. So I'm going to move the bottom window down to the two statements that create the two instances, and I'm going to move the upper window to the milk product. Now in creating the milk product, I have specified all of the arguments in this statement that correspond to those in the init statements, except of course for self, which gets automatically added to the call of the init function when the milk product class is used to create an instance. But if we look through the arguments here, you'll see that they correspond one by one to the arguments in this init function. So here's the SKU, and then the name, which is VG Skim Milk, and then the brand, which is Very Good Brands, and then the manufacturer, which is Georgia Dairy, and then the dimensions, and the weight units. There's the weight and the weight units. And now the volume, which is 1 gallon, the fat category, which is skim, the expiration date, which is expire, the serving size, which is 8 ounces, the number of servings per container, which is 16, the calories per serving, which is 90, the fat grams, which is 0 because this is skim milk, and then the fat cals, which is also 0, and finally the phone number. So in creating milk 23, I've specified all of the arguments. I haven't used any of the defaults. So let's go ahead and create this milk product. Now in creating the detergent product, I have used default values. So let's very quickly look at that. I'm going to go ahead and scroll in the top window down to the creation of the laundry detergent product. And here you'll see that I specified a SKU number and then a name, which are required arguments. And then a brands, so I created the brands here. But then I skipped the manufacturer and went to the dimensions. And when I skip the manufacturer, I then have to specify the variable name for every other argument that I use. So, for example, I've said that the dims are this list that contains 9, 3, 11 in inches. The weight is 18. The units is ounces, so the weight of the product is 18 ounces. The number of loads is 72. The suds level is high efficiency, and the form is liquid. So I've specified the suds level, the form. I didn't bother to specify a cent, so it will default to none, and then no phone number either, so it defaults to none. I just wanted to show you the two ways of calling the classes, one where I specify every argument and one where I omit some arguments. But in that case, in order to make things line up right, essentially, I have to specify the names of all of the arguments after the first one that I have omitted. So I've already created the milk product. Now I'm going to go ahead and create the laundry detergent product. I'm going to go ahead and select the line that defines it and then press F9. And you'll see the code to create the laundry detergent product is now executed in the console. So basically what I want to do next is to play with these two instances so that you see how things have been created and defined. And to do that, I'm going to go ahead and slide this console up over the editor window so that we have some room here. So the first thing I'm going to show you is that Milk 23 has all of the usual attributes defined, like, for example, its SKU. So it returns that its SKU is Dairy 23. But now Milk 23 also has attributes unique to food products, such as the number of servings. So you'll see that the number of servings is 16. It also has things defined like the serving size, which is 8 ounces. In addition, it has methods defined that belong to product. For example, I can do Milk 23 footprint area. And it will tell me that the footprint area for this milk product is 64 square inches. Or I can get the volume, so that will be Milk 23, and that function's name was shelf volume, maybe. Well, I've gotten that wrong, but this gives me an opportunity to show you the dir command again. If I do dir of Milk 23, it will show me all of the attributes. And if I look through the attributes, I'll be able to see that the function that I was really trying to call was print shelf volume. So we'll do Milk 23 print shelf volume. So we can see that the volume required on the shelf is going to be 640 cubic inches. Similarly, for the laundry detergent product, which was det 16, I have things like the number of loads, which was 72. And again, to remind myself of what the various attribute and functions names are, I can do a dir of det 16, and we'll see that I have things like the sudsing level. So let me print that out. Det 16.sudsing level, and that is HE. And I also have the inherited methods from the product class, such as print shelf volume or footprint area. So det 16.footprint area is going to be 27 square inches, and the volume that's required to put the product on the shelf is going to be print shelf volume, and that's 297 cubic inches. So I encourage you to play with these objects until you really understand exactly what's been created and what has been inherited from the product class. So I've now introduced a very important concept in object-oriented programming, and that's the idea of inheritance. The idea of inheritance is that one class can inherit the characteristics of another class, and this can be extremely useful in defining objects and in creating a hierarchy of classes ranging from the very general, like the characteristics of all products in a grocery store, to ones that are much more specific, like the specific characteristics of a laundry detergent product or a milk product.